Let's discuss about the save control statements in a Spectre netlist. The purpose of the save control statement is to save signals for individual nodes and components in the circuit. You can have multiple save statements in your netlist. With the save statement, you can save voltages for individual nodes, charge on a node where the currents will be identified by the terminal node name or the index number, all signals for an individual component, selected signals for an individual component, and to save power dissipated on a circuit. Here is the syntax, and these are few examples of save statements. Pause here for a moment to read through each of these examples. Also, note that since Spectre 17.1, you use the save statement to measure the parameters of stacked FETs, including term voltage, current, capacitance, conductance, and VTH. In this case, all devices in the subcircuit can be probed as shown in this example, where it saves the constant current threshold voltage and drain conductance of the X1 instance. Saving hierarchical information. To save information corresponding to devices in subcircuits, you must include the full hierarchical path to the device. The only exception is in the case of the inline component of an inline subcircuit. In this example, we have both the inline and traditional subcircuit definitions. If you notice the save statement in both these cases, a traditional subcircuit requires a full hierarchical name to save the VD-SAT voltage signal of the most device, whereas an inline subcircuit does not require the full hierarchical path. Also, in the case of inline subcircuit, if you save currents associated with an instance of an inline subcircuit, you are actually probing the current through the inline device, and hence the current through parallel devices will not be computed.
Now, in this window, we have a bipolar amplifier netlist with the save statement at the end of the file. This statement saves the collector current for component CCOM. It identifies the terminal with the index number 1 instead of the terminal name C. With this netlist, run a simulation on the command line by typing Spectre, netlist name. Once the simulation is completed, open the Virtuoso Visualization and Analysis, the Weaver tool, by using the standalone command Weaver to plot the saved signals. Here in the Weaver, open the results from appropriate PSF directory by choosing File Open Results. Choose the bipolar amplifier raw directory and click on Open. Then from here, in the browser assistant, expand to display the TRAN and DC results. Now click on the TRAN folder to display the signals. Here you can notice that the CCOM current is saved because of the save statement in the netlist. After selecting the signal, click on Plot icon to plot the collector current. So when you specify signals in the save statement, the Spectre simulator sends these signals to the output raw file as long as the nest LVL setting does not filter them. The nest LVL setting is nothing but a setting which specifies how many levels deep into the subcircuit hierarchy you want to save your signals. Then in the command line, to find more information on the save statement, you can type Spectre-H save.
Using wildcards in the save statement. While saving signals from different hierarchies in a large design, we may not be aware of all the signal names. In such cases, you can use the wildcards to match few names of the signals in the hierarchy, or save all the signals in the hierarchy using the wildcards. To match a single character including the hierarchical delimiter, use this question mark pattern, while to match a string of characters including empty string and the hierarchical delimiter, use the star asterisk pattern. This is syntax for using wildcards in the save statement, and here are a few examples. The first example saves the voltages of all nodes whose name starts with X from all hierarchies. The second example saves all node voltages from all hierarchical levels with all names. The third example saves the operating point parameters of all these most devices from level 3 and above whose name matches with the pattern. Then, the fourth example saves voltages of all nodes except this node in the instance of the subcircuit mem with a depth of 1, which means saving of signals happens at top level and one level below it. Then the last example saves the voltages of all nodes from level 2 to level 3 whose names start with X and ends in 1 from 1 microsecond to 2 microseconds and 3 microseconds to 4 microseconds as specified in this time window option. So you can use wildcards for saving signals selectively and thus reducing runtime, memory usage, and disk space.